projects. In this video, we are going to explain about a project titled A Machine Learning Based Classification and Prediction Technique for DDoS Attacks. The project focused on distributed denial of service attack which exploit the vulnerability inherent in any network resource, such as organization website infrastructure. DDoS attacks involve flooding the target web assets with multiple requests, often using the IP spoofing technique to overwhelm the site's capacity to handle the concurrent request. This results in the website becoming unavailable or functioning inefficiently, impacting both legitimate users and the overall performance of the network. DDoS attacks primarily target web application and business websites, and attackers may have varying objectives for carrying out such attacks. The project objective is to introduce a machine learning approach for classifying and predicting the DDoS attacks. The random forest and XGBoost classification algorithms were utilized to accomplish this task. Additionally, the project presents a comprehensive framework for DDoS attack prediction employing the UNWS NP15 dataset sourced from GitHub repository. To assess the performance of the proposed models, a confusion matrix was employed. The result demonstrated that the proposed model achieved a notable improvement in the accuracy of DDoS attack detection compared to the existing research studies. These are the requirements that are needed to build this project. Hardware requirement: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is Upload UNSW NB15 dataset. This module enables the user to upload the UNSW NB15 dataset to the application. Once uploaded, the model analyzes the dataset to identify the various types of attacks present within it. It generates the plots or visualization to illustrate the different attack categories present in the dataset. And the second module is Pre-process the dataset. This module focuses on preparing the dataset for further analysis. It handles the missing values by applying the appropriate technique to replace or impute them. Additionally, non-numeric data within the dataset is converted to numeric values using the label encoding algorithm. This module also includes the normalization of the dataset to ensure the consistent scaling of the features. And the third module is Dataset Train and Test Split. In this module, the dataset is divided into training and testing subset. The application utilizes the 80% of the dataset for training purpose and reserves the remaining 20% for testing the performance of the model. This splitting allows the evaluation of model accuracy and performance on unseen data. And the fourth module is Run Existing SVM algorithm. This employs the support vector mission algorithm. It trains an SVM model using the provided training data and subsequently applies this model to the 20% testing data subset. By doing it, calculates the prediction accuracy of the SVM algorithm on the test dataset. And the fifth module is Run Random Forest algorithm. This module utilizes the random forest algorithm. Similar to the SVM model, it trains the random forest model using the training data and assesses the prediction accuracy of the model on the 20% test data. And the sixth module is Run XGBoost algorithm. This module employs the algorithm, a gradient boosting technique. It trains an XGBoost model using the training data and evaluates the model's prediction accuracy on the 20% test data subset. And the seventh module is Comparison Graph and Table. This module generates a comparison graph and table to showcase and compare the performance of the different algorithms used, the tasks of SVM Random Forest and XGBoost. This graph and table provide a visual representation and a numerical summary, allowing for the comparison of the prediction accuracy achieved by each algorithm. And the final module is Attack Prediction from Test Data. This module enables the user to upload the test data to the application. The XGBoost algorithm is then utilized to analyze the test data and make predictions regarding the presence or likelihood of attacks within the data. This allows the user to gain insight into the potential attacks based on the analysis performed by XGBoost model. The execution of this project. To execute the project, first we need to open the code folder. This code folder consisting of different files. The first file is dataset folder consisting of the trainer data and the testing data, and the second one is model folder. This is the folder will have the .npy files and the which we contain the algorithms information. These files can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making predictions on new data or performing the specific operations. And this is the main code file, and the run is a bad file. Instead of executing the program in the command line interface, we created the Windows bad file to execute the project. And the table is an HTML document which is used for the representation of the all algorithms and the project. And now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. First, double click on the upload dataset button. Here, by this button, we are going to import the dataset from this corresponding folder and select the UNSW-NB dataset and click on Open button. Here, we get a graph where some values in the data set are having the numeric and non-numeric format, and here the x-axis contains the attack names and the y-axis contains its count in the data set. And then now close this graph. Here the data set contains of different format of numeric and non-numeric data. Hence, for this, to convert the non-numeric data into numeric format, click on Pre-processed Dataset button. Here, the dataset is pre-processed and converted the all non-numeric data into the numeric format, and we can see the total records found in the dataset is of 175341, and the total features that are found in this dataset is of 43. And then click on Dataset Prime and Test Split button. Here, by this, the dataset is splitted into training part and testing part. Here, the 80% of dataset is used for training the ML algorithm, that is of 140272, and 20% of dataset records are used to train the ML algorithm, that is of 35069. And then click on Run Existing SVM Algorithm button. By this, the SVM algorithm model is generated on the pre-processed dataset. And we get an confusion matrix for the SVM algorithm. Here, the x-axis represents the predictor class and the y-axis represents the true color classes, and this graph all counts in the blue color boxes or the wrong prediction, and the different color boxes represents the correct prediction count. And we can see that SVM predicted most of the records as of incorrect. And now close this graph. Here, the SVM gives an accuracy of 23.27 and the precision of 15.5 and recall of 23.4, F-score of 14.4. And then click on Run Random Forest Algorithm button. Here, the random forest algorithm confusion matrix is of blue color boxes, and the confusion matrix are of wrong prediction, and we can see the color boxes of different color contains the correct prediction count. And close this graph. Here, the random forest algorithm gives an accuracy of 97.9, precision of 97.9, recall of 98.0, F-score of 97.9, and then click on Run XGBoost Algorithm button. It gives an confusion matrix of XGBoost algorithm. Here in this graph, x-axis represents the algorithm names and the y-axis represents the different colors, and here the use the accuracy, precision and of it, and close this graph. Here the XGBoost algorithm gives an accuracy of 99.07, precision of 99.08, recall of 99.08, F-score of 99.08, and then click on comparison graph and table button. Here this table gives an numerical representation of each algorithm and its accuracy, precision, recall and F-score. For 3 algorithms we used in this project, that are SVM, Random Forest and XGBoost, and then close this. And here it gives an graph of bar graph. Here x-axis represents the algorithms we used in this project and the y-axis represents the values assigned to it, and each bar represents the one metric. Like of blue bar represents the accuracy, and orange bar represents the F1 score, and green bar represents the precision, and red bar represents the recall. And then close this graph and click on attack prediction from the test data, and select the test data from the dataset folder and click on open button. Here the data present in the square brackets is of test data, and after the arrow symbol we can predict it as analysis for this test data, and for this test data is predicted as backdoor. In this way we can predict the DDOS attacks by using the machine learning techniques of SVM, Random Forest and XGBoost. Finally, I conclude that project proposed a systematic approach for the detection of DDoS attacks using the machine learning technique. We used the Random Forest, XGBoost and SPM classification algorithm to classify and predict the DDoS attack types and evaluated the performance of proposed model using the confusion matrix. The results showed that the proposed model significantly improved the accuracy of DDoS attack detection compared to the existing research work. We concluded that the proposed approach can be used to effectively detect and prevent the DDoS attack on web applications and business websites.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.